Yo, yo, what's up, what's up? Yeah. Yo, 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 what's up? Hey, 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 how's it going? Alright, so we got two drives. We got a trigger strand and a drive strand, and we got two of those in this coil. So we got 4 strands in the coil. It's great. Each one of these batteries over here goes to its own drive. Each transistor gets its own drive. And then this transistor over here is also hooked up to a cap bank, which is running right now. Both of the batteries are off and, you know, recouping or doing whatever they do when they're off. And it still runs because you've got a lot of energy in the cap bank, a lot of electricity just chilling. So I'm using it to run the wheel when the batteries are off. And I never have to actually turn that off. That will run constantly. It'll run, and if you turn both of the batteries on, the cap bank will charge while it's running. It's charging right now. Hello, hello. How are we doing today? Just as with this one battery on, it's charging right now. And I turn that off and then it starts depleting. But you know, I think that's kind of cool. Nicola. Awesome. How you doing? We're going to turn it all off right now. Now there's no power being, there's no input. This thing, it's a great wheel. I just wanted to play with my dual drive electromagnet. It's like so much more energy goes through it when you got both on, then it's amazing. And then to see the difference between the two when you have one on and one off and then two on, it's like, wow, why don't they do this all over the place? And then like they do, except they do it with more than just two. You know, it's like, oh man. I'm working on a counter rotator right now. This is the base for it. And now I'm working on the arms. They're going to come up and hold the permanent magnets. And it, oh, I'm glad that did not hit my foot. Okay. This is the rotor. I think there's a lot of humidity in the air. So, what happens is each battery runs a circuit, and then off the collector goes into this cap bank right here. Both circuits go into this one, and then into the big one, and then out into this one, and then this one runs this transistor. So all that juice in the cap banks all together run this transistor. Like this. And everything has a toggle switch. So you can see the difference. I'm going to run all three real quick. Wow. I don't know how fast that's going, but it's pretty fast. We're at 10.5 volts. 10.6. 10.7. 10.8. Turn these off. Now I think what would be really cool is to have another dual drive coil on the other side and use what's in the cap bank to run off the collectors, you know, to just refilter everything. But I was working on something last night. I could hook that up real quick. So I have to actually get another magnet on the bottom of that. Huh. Okay. So here we go. See, that's still spinning like it never turned off. Hmm. Oh, I do have to do that. What do we want that to be? Let's see what this is right now. So north. So south. And this magnet right here has got the least magnetism of all my magnets. My first toroid, toroidal ferrite magnet. good that nothing's far away right now. It's all right here in my face. So it isn't perfect. I don't have a way to make it right now. I just have to get it, because it popped off. I gotta get it to pop back on. Give that a couple minutes to bond or set. Not a minute, like a couple seconds. Take that one off, flip it over. That might be a little bit of an issue. Oh no, totally didn't. Gotta borrow some bearings. I guess we're gonna do these ones real quick. So that's still printing. We're in. So what I did is I took all the 32 gauge strands and all the coils and I linked them together in series and dumped them into the bridge rectifier. And the bridge rectifier dumps into the capacitor right there, little super cap. And then from there it goes to the 26 gauge strand, which is being triggered by a reed switch. And I played with this for like, just because. I mean, I know it didn't work. It didn't work any of the times that I did it, what I wanted it to do. But that wasn't really what it was about. It wasn't about making it work. It was just about, I can't even really answer that. But, self-sustainability. Can it run itself for any amount of time? And the answer to that question is yes. Yes, it can. Can it run itself forever? No. Absolutely not. There's no battery on here, so that's what I mean by self-sustainability. It generates its own power. It's 2026. But what I am going to do is I'm going to hook this up with some lithium-ion batteries. Its sole purpose is going to be to run, spin, generate what it can for itself. It's probably going to be an LED, honestly. But there's going to be 3 batteries on it. There's going to be 3 drive circuits. I'm printing off this part. I'm printing off a new part for that. It's going to have 8 slots for magnets instead of 6. You know why I'm doing that? Because the rotor in the middle has 8 coils and it's very well balanced. It's very nice. Now let's see what happens when I spin it the other way. Shoot. That wasn't supposed to happen. Counter spin it the other way. See, that's because there's a reed switch on there. It breaks extremely fast. That's because of the circuit that's actually functioning. Spin it this way. And that'll continue to spin until it stops instead of being braked upon. This is a counter-rotating DC brushless motor. Nothing supposed to about it. Well, actually, this is pre. I haven't hooked up any of the stuff yet. But I have everything I need. So if you guys want to watch that, I can do that. But this is a self-runner, okay? And obviously it doesn't run very good. But here, we're gonna, just to prove that it's running at all, we'll do the same test we just did. since it's on a reed switch, spinning it in that direction breaks it very fast. It slows down really, really fast. Okay, now we'll do it the other way. Oh, just as fast. That's awesome. Maybe I had that one wrong too. That could just be a lens effect. But all that stuff aside, this is all experimental, and I pretty much don't have any idea what's going on. I do know lens is affecting this. See, that's a lot of lens. You know what'll stop that, actually? And you know what? I don't even think that the magnets were in appropriately. Like, they were all, I just put them in there to put them away. Alright. That reduces the lens greatly just by removing magnet. Yeah, it is a generator, but it's not put together yet. Let me show you what I mean by that. See, I got batteries to put on it. See, it works a lot better with just two magnets for the self-running aspect of it. And I'm going to put 3 batteries like in the center. And then I'm going to use these little breadboards in front of them to hook up all 3 circuits. There's going to be 6 180-degree coils involved in the 3 circuits. And then the other 2 coils are pure induction coils. So when this thing gets going, you'll get a little spike from that, as long as you have your bridge rectifier available. Yeah, that's what I'm talking about. That's it right there. We had too many magnets on it. Without power, and it's 8 coils and 6 magnets. There's obviously some sort of mix up there. Alright, let's see. We spin it the other way. If we can get it to slow down quicker. Like, I think I'm seeing it slowing down quicker. I mean, I might be crazy, but See, in the way that I'm going to set it up, it'll run with just the 2 magnets. But I'm making a stator thing for 8 magnets. It's going to have 8 arms, like sticking out of it. This is it right here. Maglev up the wazoo. Wow, man, that is spinning fantastically. So there is a little lens here, but not nearly as much as there was before. And I bear witness that these coils, the way I have them set up, generate constantly 0.05 0.05 to that cap bank. I'm not sure what the frequency is, but it's 0.05. Terrible. It's not a good generator. At least not at the speeds I use it at. I mean, it could probably get better if it went faster. And I think we're getting cogging going on here. No, that's not it. Yeah, a little bit. All right. I just love how smooth it is. And I mean, if the idea is for it to self-run, we would want as little lens as possible. So I think this is the right direction. But I would go, honestly, with like, I do the math so that the input is like unity to the output of your coils. It might be pretty close. I mean, I don't know exactly what I'm trying to say. All I know is that if you get there, then you know you can continue for until something breaks. And then over unity, I guess you can start sharing that with other things like appliances and whatnot. But if you like try to load down the unity, you're probably not going to continue to be in the unity state. So I mean, if you're doing it math-wise, you would want to factor all that into your initial equation. I love this thing. I love this thing, man. Oh, man. I am dreading building it, though. Because there are so many more wires here than there's been in any of the other ones that I've done. And I just want to get them all where they need to be, maybe shorten some of them up. That's the thing I want to do without messing up, is shorten them up a little bit. What's up, Sonic? You can hear the reed switch kind of ticking like a heartbeat. Because there's only 2 magnets on there. And yes, when you're counter rotating with this, you generate at least double, if not more, of what you would without counter rotation. It's that, I mean, it's not going to be great because these coils are small, but it is that good to have counter rotation. It is that good. And how I figured that out was I ran the counter rotator with a capacitor hooked up to it. And then when it stopped, or when I stopped it, I measured the capacitor, you know. And then I had it stopped, like so, hooked up the capacitor, and then the outside would measure, you know, spin. And, you know, you try to get the same amount, and it wouldn't even be anywhere near the amount. It's like very important if you're going to make it a generator. Now, I don't think much is being generated with the two magnets. I don't think there's much being generated at all. So if there's anything going on here besides, you know, thrust from my finger, you know, like this, that's going to make it spin for a while, it's going to be very non-noticeable. But I can guarantee that it's happening. Because I've measured the bridge rectifier while the outside was moving, and that's when I got 0.05. And then I tried it from a dead stop, it was 0 at a dead stop, and then 0.05 when I spun it up. Seems like there might be a bad connection in there somewhere if it's just 0.05. I mean, that doesn't seem right to me at all. But it did fluctuate when I stopped it to 0, and then up to, you know, it might be right. Love that, man. It's still going. So yeah, we're gonna give it some power. And then we're going to give it some circuitry. It's going to be a basic Bedini circuit. We're going to be using trigger strands. I mean, that's sounds good to me. We're going to have 3 Bedini circuits on 3 180 degree, 3 different 180 degree coil layouts. Oh, I said I was going to draw that. Be sure easier than like trying to hold 3 sticks. All right, so It's gonna be like this. And then the induction coils will be 180 like this. So it'll be like that, but this right here will be all drive. It's cool. I think it's great. Puts my mind at ease. I don't know. I'm thinking more about what you'd be making it out of. I don't know, man. I really have no idea. But I don't. You mean just out of copper? You make an electromagnet out of neodymium? Sorry. And copper? I'm trying to grasp what you're talking, I'm trying to visualize what it is. Is that, you think, yeah, that's kind of what's going on here. You got your copper, you got your neodymium magnet, and then when I put power on here, you're going to have current. But, I don't know, like, 100 pounds. I wonder how much, these are 600 pounds a piece. And they came together, so they're not coming apart. I don't have the tools to do that. But, I gotta think about that one. Right now, there's no current that I can, like, measurable current. It's being generated on a 32 gauge strand, so 0.0025 of a milliamp. There's no power on this right now. It's only being generated, any power that's being generated is being generated by itself. It goes through the 32 gauge strand, through induction of these two magnets, and then boom, it all pours into the bridge rectifier because the two ends of the series circuit are hooked up there. And then it comes out into the cap bank, or this little, super cap right here. And then the super cap is hooked up to the 26 gauge strand on one end, and the other end of the reed switch on the other end. That's this yellow one right here. N52. They're N52 neodymium. And just to give you an idea, they can touch, the fields can touch each other from where they're at. For sure, like, noticeably. Hey, this is a counter-rotating DC brushless motor, Bedini style. Not yet. Not yet. Right now, currently, it is an experiment. Right now, it's got the 32 gauge strands. I'm just telling you what it's gonna be. All right. Right now, it's got an induction generating situation hooked up to a bridge rectifier that is feeding a drive circuit on a reed switch. And we get it to spin pretty good. I mean, I had to reduce the lens. I had magnets in every slot. It was way too much. Way too much. Yeah, this is just me messing around. That's what this is. You're never going to find out if you don't mess around, right? I got an accounting degree. And I don't know, I started doing this about 3 years ago. I'm 100% YouTube educated on all the electronic stuff. As much as I could understand. You know, I don't speak the lingo, so when everybody's like across the coil and this and that, I'm like, I don't know what you're talking about. I don't understand. I'm doing the best I can, and you know, some of my stuff is better than others. I gotta admit, like I had this nice, like saucer one. You might want to check it out on my channel. That fell apart because it was going too fast. Like the inner rotor was going so fast. It had a bunch of these magnets in it, and it was just not thick enough to withstand all the force that was on it. And one of the legs broke. And 3 legs. There were 6. This was a 6-on-6. It was so beautiful, man. It was great. I got crushed emotionally when it fell apart. I was just so excited, and I changed the coil hookup to single coil per battery, and it just started going so fast, and it broke. And you don't want to just rebuild it. You have to change it. So it's not like you can just, fix it. You're going to fix it by making a new one. Thank you. All right. So, I had a triple one. Still do. It's over here. So this is the outer rotor. Okay, we got to do this a step at a time because the bearings aren't in this one. So this is the outer rotor, and it goes on the bottom. This is the middle rotor, and it's got all the coils on it. And it goes inside the one I just showed you, like right in the middle. And then this is the inner, or the center rotor. And it syncs up with the outer rotor. So this is north, and the one facing it on the outer rotor is south, and they couple very well. So when you spin the outer one, the inner one spins, and those coils are getting, bombarded with magnetism from both sides. It's awesome. It's too bad you can't hook a meter up to it. This is an experiment for a self-running machine. It doesn't work. Of course, it doesn't work, but you know, my idea was to have the induction coil, right? Which would be a series connection of all these coils. And then you put it into the bridge rectifier, which is right here. And then from the bridge rectifier, you go into a cap. And then from the cap, you go to the 26 gauge strand, which is hooked up to a reed switch. And there's no power to start out with, so there's no like compensation that you have to make when you turn the power off or whatever you were going to do with power. But what this is going to be is a counter-rotating DC brushless motor. It's just I'm messing around with it before I put it all together because I want to do that. Hey, what's up? What's up? Yeah, what's up, Papa Bale? All right. Yeah.
Thank you.
You're welcome. Yeah, I know. And my door's coming off the hinges. Another one that I was trying earlier too. Is 120. See, there's not as much as there was with 6. There's more than there was with 2. But there's going to be a lot more induction going on here with 3 magnets than there would be with 2. But it's all uneven to the center, which is 8 coils. You know, it's all uneven. 3 doesn't really do that well. Or maybe it does it better, who knows? Me personally, I like it when things line up. Somehow. Oh yeah, my phone is connected to my car. I hope that didn't interrupt anything. See, none of this stuff on the top is glued down. That's why I'm not whipping it so to make it go real fast. And maybe, I think it might even work if it goes real fast, but Um, yeah, I'm not going to glue any of that stuff down or tape it down or solder it in or any of that crap. It's an experiment. Meaning definitely not permanent. Awesome. Get a little bit more speed on that. Oh yeah, that frequency is way different than with the two. I mean, so different. See, I know right now we're not generating enough to overcome lens effect. It's like 0.05. That's how much I was getting off the bridge rectifier. But the same set of circumstances, I didn't have anything glued down, so it was very slow. Let me see how close we are with this handle. Oh yeah, we're almost done here. I think we're about 95%. So I'm trying to psych myself out into building this thing like tonight or something. See, but even with 3, it starts spinning the other way a lot quicker than, with just 2. And the 8 magnets work with 2. The way I'm going to set it up anyway, with the 180 degrees, it's going to work really well. Heck yeah. awesome how interchangeable all this stuff can be if you build it right. Hmm. So that's now so. And the thing that I'm printing right now is going to go on this gray thing down here, hopefully. I don't know what that is, but I would say no. I am I'm building another counter rotating pulse motor. I'm just waiting for the thing that's going to hold the magnet. And I think it'll spin right when all the magnets are on there. I mean, just continuously instead of just for a little bit. Not forever, just longer than it is. Oh no, sir. I don't know about like future applications, but I'm not trying to make a hover bike. I can't. This thing won't fly. You make it into something totally different, and then it'll fly. Yeah, I don't know if I'm going to be able to use this. It looks a little wobbly, flobbly. And if I make another one, I'm going to make it a different, a multi-sided shape, like a polygon, instead of like attempt to make a circle. Oh, sorry, buddy. The only reason I'm making another one is because the one that's over there has 6 magnet slots, and I need 8. Otherwise, I'd just continue to use the other one. Yeah, definitely a polygon. That'd be awesome. You see how much time? 3% more to go. We'll see if these go, marry well. If they come together well, then I'll continue. Or the arms will be able to be pulled out. So I'm just going to continue making arms right now. And what the arms do is they hold the magnet like right here. Yes, a rhombi cosi dodecahedron. That's what I said. And another way you can tell that a self-running unit is working, if you set it up the way I set it up, is that it will never go as far as if you didn't have set it up at all. Like, see, look at how much this is spinning, and there's no magnets involved. Same hookup, but there's no induction, so it's like might as well not be there at all. And it's spinning very smoothly. Why that one? Specifically, because I made that one, 3-dimensionally. Yeah, man, it's gonna be great. I don't know about this gray thing though. With enough torque, it should overcome any obstacle, but yeah, that's pretty good. Oh, that's all right. Indeed. It was a little confusing, but I got it. It's amazing how long 3% takes at the end. It's like, come on now, here we go. Let's get done. But then you want it to be nice, you want it to be good. There's lots of plateaus on this, so it's like just taking a while. So I'm gonna, if it fits right, I'll continue to use this until I make one that is more, what do you call it? Balanced? I'm gonna call it balanced. And I heard that the way to do that was to make a polygonal, a shape with odd amount of sides and even amount of points. Yeah. None of that stuff is really easy to like project. Either to draw or to three-dimensionally create it. You know, it takes a lot of focus. Especially if you're not using a ruler or some sort of straight edge. Oh, here we go. Watch it be all wrong. Watch it be all wrong. So it's like that. And I don't even know if this one is right, but we'll find out. Huh, it's the wrong size. I think. And that's okay. You know why this is all okay? Because I wonder if it's I think it'll fit. It's not A snug, it'll be a very snug fit, I mean. So, anyway, that's the way they're supposed to go in there like that, and then they're supposed to rest this part, they can rest on it. It'll fit in there just like that. Oh, man. So, in order to make this fit, I'm going to have to shave off the edges here. And then it'll fit in there, and then I hammer it in. It'll be a permanent thing. I don't know if I want to do that with this particular one. Look at how not right it is. All right, that makes sense. There it goes. So that's all you really need to get it in, and then hammer it home. So maybe. So I just kind of want to get it in. And see if I even got the angle right on the arm. Because that was a up in the air kind of thing. So that's way, well, if you hammer it in, it'll be right. Alright, so let's see. That's literally about 3/4 of an inch distance. So I might need to shorten it up a little bit. Well, my printer has a range of 8 inches. That's what the point is. This disc under here is 8 inches and it's not big enough. So therefore you need to add the other ones. Unless you're going to buy me a bigger printer. Rock on. takes. It's hot, baby. So I got this axial flux rotor that I might turn into a counter rotator. Oh yeah, I've made all different kinds of them. I've made triple counter rotators. I've made all different kinds of them because it's challenge. There's a challenge there that is not inherent in any of this other stuff. The challenge is to get the readings, get all the information that you would normally get. It's like almost impossible to get in this situation. You need a commutator, you need slip rings, you need a lot of things just so you can hook up a multimeter. Yeah, man, but none of them are around anymore. I've had to salvage pretty much everything that I built to build more stuff. Because, yeah, man, I like doing it. I like doing it, and in order to do it the way that I want to do it, I have to be rich. So I just do what I can. I think it does, and is for the exact same thing any of these other motors are for. And what they do, it's exactly the same thing. So, I mean, it's a moot point, a moot question. If you know what any of these other kind of motors do, you know what a counter rotator does. It just does it better. And I don't know, like, that's not true. That is so not true. What I just said about it doing it better, it does it differently. In order to get the equivalent reading, you have to counter rotate. I mean, and I've never got it to go like, I've heard that at high speeds, there's time stuff that goes on. But I can never get it to go that fast. I don't want it to go that fast. I really don't. Well, I've never actually applied any work to it. You know, I've never seen. You know, I swear that it could, if you put a little spindle on it, you can wind up your extension cords. You can probably wrap a coil with this thing. You know, a lot of people said, you know, record player. Well, if you use a record player to spin your coils, you can use this to spin your coils. Does it have to be this coil setup? No. I don't believe in that kind of stuff. You know, the coil is a variable that you can change at your whim, and you probably would. You know what I'm saying? Unless you like, I don't know, there are probably people that don't know absolutely anything about it. And then in that case, they probably would replicate so that they can see it work. But, I mean, this is like one of those things that is designed not to do. I mean, it'll charge a battery, it'll charge a capacitor, it'll light an LED. But the minute you try and hook like a 12 volt DC motor up to it, one that goes, you know, 3,500 RPMs, it doesn't want to work because there's no amperage. Absolutely. All of them are pretty much just experiments. Because, and the main reason is because I don't want to replicate. Or I would have made, you know, a Newman motor, a Bedini motor, and tried to do it the way it was done in the book. You know what I'm saying? That I would, and then I'd actually have some of those answers for you. You know, what I could do is I have a website, and it has tools in it that you can use to, you know, find out the henries of your coil. You know, the inductance, and you can find out all that good stuff on the website using the tools. And I you know, I should probably do that for this coil, because when you turn on one drive, let's turn on the cat bank. So we just turned the cat bank on and we're still charging it. That's awesome. That's great. And that's just one drive on. But now that drive, this transistor has got two things powering it right now. And then now I'm going to turn on this transistor. We're now charging at 1.5 times the rate, so almost 2 times the rate. Maybe 2 times. Could be more. You know, like 2.5 instead of 1.5. See now, the cat bank is on and powering that transistor, but it's still charging. And I love that. I know I just said that, but I do. Well, to understand the purpose more, you got to go into, you got to know me a little better. It's not about really what's going on the table. It's about what's going on in my head. This stuff soothes me. You know, and then, you know, whatever doesn't soothe me, I tend to stay away from. So, like, if it's all hard work, but if it gets to the point where it's like, yeah, no, unless somebody gives me the frickin' answer, I'm not going to do this anymore. And I've been there too, you know. It's like, hey, but I love doing this stuff. Anything, in my opinion, and that's why, you know, I can't respect a lot of people's opinion, because anything that functions, in my experience, since I'm an accountant, any of this stuff that functions is a success. I don't need to put a load on it. I mean, I can, and I should, and maybe I will later, but, you know, I don't need to put a load on it. I don't need to do any of that stuff, because I'm doing it for me. And I know, like, people that are involved with it say, you know, you do, and these are the reasons why. And I'm like, yeah, I get that. And when I can figure out a way to do it, but a lot of people, they just don't come by as, you know, trying to help out. They're like, hey, you don't have a purpose, you might as well get lost. And it's like, hey, man, that's none of your business. So now we're running on the cat bank. And both batteries have been off for, you know, 8 minutes while I've been talking. Yeah, a lot. There's quite a few people out there that haven't seen the kind of rotating stuff. Come on, level out. I know you want to. I mean, it's nice and smooth. It's just the bearing has got, like, space. There it goes, there it goes. There it goes. Hey, Yanni, what's up, my man? That's right, Pulse Motor Mayhem. All is well, Yanni. Good to hear from you. We're still charging, just at a minimal rate. And boom. Now we're spending. I love it. Oh man, my daughter was playing with my tack meter. I wonder where it is. cold. Huh, man, it's blazing here in Michigan. So the other aspect of this build is those two coils over there, the gray ones with the blue tape. They're induction coils, and when this thing is just spinning, there's one more opening going into the cap bank, so it'll all end up being spent. But it'll, elongate how long it'll take to spend it. Now that's the frothy stuff that I'm talking about. That's, you put the coil next to the magnet and you get a little charge. But like 70% of that charge you're not going to be able to use. And there's no amps with it, there's like barely any amperage. At least the way I have it hooked up. Using just pure permanent magnet induction. And this thing will spin for, 30, 40 minutes. Wow, it's charging so fast. For 500 farad, this is amazing. This is great. It's literally two parallel circuits dumping into the cap bank at the same time. It's awesome. Yeah, they're hooked up in series. Kind of want to hook those up, actually. Oh man, but I need to get the green coils to stand them up on, because as you can see, they're small. They're not high enough. Yeah, man, the Straight Dope came out with his own song, man, and that thing it's a cool song. Heck yeah. Well, there's not a lot of copper in those coils. It just has a really big axle. Yeah, it's 32 and 28, maybe. 26, 32, and 28. So I was thinking about maybe putting a relay, a timed relay, on the cat bank and this battery, and have them make it so that when the two batteries are off and the cat bank will be off too after it's running for a while, and everything shuts off, and then the cat bank turns on. And then this battery turns on, the cat bank turns off. And then that battery turns on. And then everything shuts down. So what you're trying to do is you're trying to spend the cat bank energy first, get it all gone, charge the cat bank up again, shut everything down, and just complete that cycle over and over again. How much amperage is being drawn? I don't know. I'd say it's quite a bit, actually. Probably more like 400 milliamps, I want to say. I'm not sure about that. But I ran it on a power supply, and that's how much amps it drew from the power supply, if I remember correctly. I don't have any of those like clamp things. I don't have any of that crap. I do know that I don't have the tools to measure amps correctly. Test the voltage and the resistance of the coils, okay? You forget, my brother, I am an accountant. I mean, I, some people have mentioned Ohm's law before, but I have no idea what Ohm's law is. But that sounds super easy. I'm just so not, I'm loving how the axial flux is actually way smoother in this regard than radial flux. And it's all orientation based. And so I'm like, that's cool. You can make it that much better just by changing where the magnet and the coil are oriented to. So right now, there is 0 amp draw. And if those coils were hooked up right now, we'd be getting free energy, basically. Okay. Okay. You know what? I'm gonna write that down. Yeah. Well, I'll do that and I'll write it down and I'll let you know, come back around. Oh man. Oh, it's so hot. All right, everything's off, so I can find the ohms or the resistance for the drive coils. Three 3.9 ohms. Oh, yeah, Yanni. Cat banks are awesome. They're I think they're way more versatile than batteries. They're just not as powerful consistently. So 3.9 ohms. Let me write that down. And that's for both of them because they're equal size. All right, it's going to be AC voltage, right? From the coil. Look, man, I failed algebra 4 times, so yay, yippee. That's all I gotta say. Thank you, though. I was really good at math up until I screwed myself over. All right. So 0.2 of a volt Should I turn this on? I don't know. It doesn't specify in Ohm's law whether it should be running or not. Counting has nothing to do with math, bro. Oh my God, no. Accounting, that's a myth. That's a misconception that accounting has anything to do with math. This right here is it's a motor generator. It's off right now. I need to know uh, what kind of voltage I'm supposed to be getting off this thing though. No, this one right here is a motor generator that spins. It lights. It can light up lights. Does a lot of things, but right now it's just spinning. It just spins right now. He's absolutely right about that. But like I said, everything on the table is a variable. Okay? And I know it's hard for a lot of people to grasp and understand that anything on this table is subject to change at any time. So there is no concrete purpose because the purpose could change at any time. But I'm gonna turn this on with the multimeter clip to the drive coil. Let's see what happens. Okay. We're getting induction magic. So we're almost up to 4.5 volts, 4.6, 4.7, 5 volts. That's all induction, so I don't think that's right at all. There is a little bit of math, understanding of math that needs to be in accounting. Most of it is understanding. Story problems is really big in accounting. Yeah, but it's majorly counterintuitive to the typical mathematical principles. So I'd say about 3.5, no, 3.2. So the impedance of this coil appears to be quite low. So awesome, we're back in business. Awesome, Cyanide, you're awesome, dude. I'll catch you later, thank you. I'll try to get the information that you were asking for, just for myself, you know. So what you been up to, Yanni? Been looking forward to more videos. Did you make those Bedini circuits on your own? Did you solder that stuff together by yourself? All right, man, that's sweet, dude. I'm liking that. Yeah, there's a lot I need to learn about making videos myself, even though I have, you know, roughly 4,600 videos. They're all like of me holding the camera, pointing at something and talking. You know, that's the extent of my video making. And then I have an Opus clip, which takes my old long form videos and makes them into short form videos. And I only do that with things that I think should be looked over again. You know, if I think it should be revisited, then I will Opus clip it. And a lot of people don't like Opus clip because of the context is, you know, choppy when you're breaking down a long form into a short form. But Opus clip is great. See, I've made 3,500 videos and Opus clip has made the rest. It's a great help because I'm exhausted all the time. Ah, all right. Well, that's good news. I did just change it up again so that I would have more room to move around. And I believe that I am vocalizing a lot better than I have been in the past too, so that's good. I didn't think I'd be able to hook up the capacitor bank and the battery to the same transistor at the same time, but I can. It's awesome. Now, what would be really cool is if now, since I moved the multimeter off of the cap bank, I could take two more clips or wires and hook up this transistor. It's going to take a lot more than what I just said to make that happen, so I don't know. I have to change out the big clips for the small clips so that all three would fit. I'm just weighing whether I should do this or not. But there's no power going into this right now. I think that's awesome, like in and of itself. I'm going to see if I can't find those green coils real quick. These little green ones are going to be pedestals. Bam. Perfect. We got 2 clips left, and this is exactly what they're good for. All right. And that's that. So now the induction part's set up. One from before the coil and one after the drive coil. Blow me. Suck a fart on my butthole. Loser. This jersey's awesome. Freak. Alright, my man. I'll see you later, guys. And thank you all for coming by. I really appreciate it. Adios. See you next time.